Hello, everybody. The last time we met, we were talking about using the number of hours of daylight to predict our location on the globe, or our latitude. And we had seen this 3D model before, and I've since added a few locations to it. So just a quick recap. The light blue represent locations directly at the equator. It looks funny now because of the angle. The pink is representing Hawaii. The blue is Lexington. And the black is Berlin, Germany. And what we learned last time was that as the latitude increases, the amplitude of the curves increase as well. And this is, of course, is reduced now to the northern hemisphere to kind of reduce clutter here on the graph. Since we've last talked, I've added two locations to the northern hemisphere, the purple and the green. The purple represents Barrow, Alaska, and the green represents the North Pole. This is really important for us because what we see is that our ability to use a sine curve to model the number of hours of daylight breaks down since it kind of plateaus at the top and at the bottom. So what that means is that for the purple graph in Barrow, we see 3 months, those 3 arrows at the top, where there's 24 hours of daylight, so the midnight sun. So the same thing is true in the North Pole, except it's 6 months. So this is a problem for us because there's going to be locations inside of the Arctic Circle that receive the same amount of daylight on any given day, whether it be 24 hours of daylight or 0 hours of daylight. And we won't be able to predict where inside of the Arctic Circle we are if we know that there is 24 hours or 0 hours of daylight. I'm going to spin the graph around now so you can see it as the perspective changes. And there you see the plateauing really well. And the North Pole, there's only one day where the sun is rising and one day where the sun is setting. Otherwise, there's always either 24 hours of daylight or no hours of daylight. So the end result is that our ability to predict is limited to locations between the Arctic circles, the Arctic and Antarctic circles.